In this video, we're going to look at some basics of working with vectors in R3. So up here I have just a generic notation for a vector in R3. So you would know that this is a vector partly because of this notation with the barb over the V, and also because of the brackets, the pointy brackets surrounding that would indicate that that's a vector. And I've got three components here, so this would indicate in R3. So we'd have something parallel to the x-axis, y-axis, and z-axis here. So we're going to look at a little example over here and then some other things that we might talk about with this particular vector. So for example, we might have a vector that is, say, 1, 2, -3. And so if I wanted to sketch that vector in R3 in standard position, I would need my three-dimensional coordinate system here. And so without labeling them, if you haven't labeled your coordinate system, I would assume that that is standard orientation of the axes. So your positive x-axis would be forward, your positive y-axis would be to your right, and your positive z-axis would be up. So that orientation of your axes, if you want to label them, fine. If you haven't labeled them, then I would assume that this is the orientation you have. And if I'm going to draw this vector, let me draw the vector actually in a different color here so we can distinguish it from the axes. I would come from the origin, I would come out 1 unit, over 2 units, and down 3 units. So let me scale off my axes here. So I've got out 1, over 2, and down 3. And just like when we plotted points with in R3, you have to be a little bit careful when you do that you're making things line up correctly. So when I come out 1 and over 2, I want to line up where that would be. And then from there, I want to go down 3 units. So I'm looking at this 3 units here, and I'm bringing that down 3 units from where I was at when I came out 1 and over 2, and then down 3. So I'm going to put a dot there, and that's going to be the terminal point of my vector. So one mistake that sometimes students make when I ask them to graph vectors is that they just plot the point. So the point is not the same as the vector. That's the terminal point of the vector, which if my tail is at the origin, the terminal point of the vector is at 1, 2, -3. Notice that sort of convenience there about that relationship between the vector components and the coordinates of the point. But the vector itself is that directed line segment that would have its initial point at the origin and its terminal point at 1, 2, -3. So there would be a picture of my vector. All right, so a couple of things to talk about with that vector. We talked about that we can think about a vector as something with magnitude and direction. And so when we think about magnitude, we just want to clarify what that means. Magnitude means the length of the vector. And so really what we're looking at here is a distance between 2 points. And so there is a formula for magnitude of a vector, but it is really just distance formula, the distance between 2 points here. And so my initial point's at the origin, my terminal point is at the point 1, 2, -3. We should be able to kind of pretty easily think about the magnitude of that vector. I'm going to write the formula down over here along with some notation, but this should not be a new formula for you to memorize. You do need to know this formula, but it shouldn't be a lot of effort for you to memorize that. For notation, when we want to talk about magnitude of a vector, we'll put these little bars here that look like absolute value bars around this vector symbol. So that would mean the magnitude of the vector v. Or in some textbooks, they'll use double bars. Our textbook just uses a single one, but this is a common notation as well. Either of those is fine. I will try to stick with what our textbook does, but if you write the other one, that's perfectly fine. And the formula for that is really just distance formula. So the square root of the distance between the terminal point and the initial point. So that would be from 1 to 0. So notice that that really is just this component here, squared. So v1 squared plus v2 squared plus v3 squared. Remember when we looked at distance formula before, one of the ways we talked about that is change in x squared plus change in y squared plus change in z squared. And really that's what these components are. Distance between the initial point and the terminal point here is just your change in x, your change in y, and your change in z. All right, so make sure you know this formula, but this formula shouldn't be something difficult for you to learn. So for this vector here, the magnitude of this vector here, notice I'm using the correct symbols here, the magnitude of the vector v is the square root of 1 squared is 1, plus 2 squared is 4, plus negative 3 squared is 9. So be careful when you square that negative. So square root of 14 in exact form. If you want a decimal approximation, okay, but in general, in this class, we're going to leave things in exact form. All right, and then a couple of other special vectors to talk about a little bit. There are some vectors that have special names that we want to talk a little bit about. One of those is what's called a unit vector. A unit vector is a vector of length 1. And so this one is not a unit vector because its length is not 1. But unit vectors are really important in a lot of the applications we do. So when it talks about something that you need for a definition that needs to be a unit vector, you need to remember that that vector needs to be length 1. And so one of the things we'll talk about in the next video is how to rescale so that you can take a vector of a particular length and rescale that so that you can get a vector in the same direction but length 1. So we'll talk about that in the next video. But anytime you see a unit vector, that means the length is 1. We have 3 special unit vectors that are called the standard basis vectors for R3. And you don't need to necessarily know all of that, but you do need to recognize these symbols that I'm going to write here. So these are all unit vectors, and they are very specific unit vectors. So one of them is called I, and it is the vector 1, 0, 0. So if you think about drawing that on my coordinate system over here, I would put my tail at the origin. I would go 1 unit in the positive x direction. And then J is the vector 0, 1, 0. So that vector, tail at the origin, would go 1 unit in the positive y direction. And then the vector K is the vector 0, 0, 1. And so that one with tail at the origin just goes 1 unit up. So you can see that these ijk vectors basically construct our x, y, and z axes here. So these are called standard basis vectors. Anytime you see these symbols, I, J, K, in this context of vectors, and again with barb over top or bolded in your textbook to indicate that it is a vector, you should understand that that's what it's talking about, is these 3 vectors that are parallel to the x, y, and z axes. And those, notice all, are unit vectors. So those will be important in a lot of things that we work with later.